This is the lesson for trigonometry for block day, Wednesday, January 30th and Thursday, January 31st. In this lesson, we are going to be solving right triangles to find missing sides and angles using the sine, cosine, and tangent functions and using our calculator in degree mode. So before you start doing this assignment, make sure you switch your calculator to degree mode. As you look at example 1A, the triangle has two sides given and a missing angle. As you look at the sides that are given, they're the legs of the right triangle and the hypotenuse is not involved. That means that you're working with the tangent function. So in this diagram, the tangent of angle x is equal to the side opposite 45 over the side adjacent 55. And we would actually write that equation. We would write the tangent of x degrees equals 45 over 55, which, let me put that back in the view. And how we're going to solve this with our calculator when we're finding a missing angle is to use the inverse trigonometric function. And that would be the inverse tangent. And so x, and I'll move this up, is going to be equal to the inverse tangent of 45 over 55. And as we go to find missing angles, we want to round angles to the nearest degree while we round sides to the nearest angle. So on my calculator, I am going to press the second button and tangent. It looks like it says tangent raised to the negative first, but that is called the inverse tangent function and allows us to find the angle that has the tangent ratio of 45 over 55. And we want to round that to the nearest degree, so we would round this to 39 degrees. In example B, the triangle involves the same sides, the two legs, and the acute angle that's 30. We're not involving the hypotenuse, but we're not trying to find the angle, we're trying to find the missing side. But it's still the tangent ratio, and what we would write is the tangent of 30 degrees equals the side opposite, which is x, over the side adjacent, which is 10. And the best way to go about solving this is to treat it as a proportion. Put that trigonometric ratio over 1 and take the cross product. And when we take the cross product, x would be equal to 10 times the tangent of 30 degrees. We're very careful to write it as 10 times the tangent of 30 degrees instead of the tangent of 30 degrees times 10, because when you don't use parentheses, it sometimes thinks that it takes 30 times 10 before you take the tangent. So I would get in that habit of taking 10 times the tangent of 30 degrees. And we will round that to the nearest tenth, so that would be about 5.8. In our next diagram, you'll see that the hypotenuse is actually involved this time. It's actually our missing side, and the leg we're given is actually the leg adjacent to our 25-degree angle, which means we want to use the cosine function because cosine is the ratio of the adjacent side to the hypotenuse. So what we're going to write here is the cosine of 25 degrees is equal to the adjacent side, 42, over the hypotenuse, which is x. Of course, treating it as a proportion, putting the cosine 25 degrees over 1, when we solve that proportion, this time we get x times the cosine of 25 degrees equals 42. And this equation will require us to divide to find the missing side x. So x here would be equal to 42 divided by the cosine of 25 degrees, which means x is going to be approximately, and I'll use my calculator here, 42 divided by the cosine of 25 degrees. That is about 46.3. Again, we're going to round our sides to the nearest tenth. So we've got 46.3. Diagram 3A. This time, again, our hypotenuse is involved. Anytime the hypotenuse is involved, we're either dealing with sine or cosine. But this time, unlike diagram 2, the side that's involved is the side opposite the given angle, which means we're dealing with the sine, since the hypotenuse is 32. And so here, the equation would be the sine of 14 degrees equals the side opposite, which is x, over the hypotenuse, which is 32. And then to solve, we're going to treat it as a proportion, put that trigonometric ratio over 1. That gives us x equals 32 times the sine of 14 degrees. And using our calculator to approximate, we've got 32 times the sine of 14 degrees, and that is about 7.7 when we round to the nearest tenth. Finally, the last diagram. In this last diagram, we are trying to find the missing angle. The hypotenuse is involved, the side opposite is involved, so again it's sine, and we're going to have the sine of x degrees equals the opposite 14 over the hypotenuse, which is 22. But again, when you're trying to find the missing angle, you need to use the inverse trigonometric ratio function. And on your calculator, that will require you to press the button second and then sine, and then we want 14 over 22, and we're going to round that. Now that's like right in the middle, so normally I might round that to 40 degrees, but I can see how 39.5 degrees or 40 degrees, if you're rounding to the nearest degree, would work. So when you solve the worksheet that will be on my webpage, you need to make sure you show your setup with your trigonometric equation and your work to solve. You should be able, in most cases, to do that work in the space if you print the worksheet off or do it on a separate sheet. For each of the problems, it is 2 pages, front and back, or 2 separate sheets. And round angles to the nearest degree and sides to the nearest tenth. And we'll continue on this lesson when we return to school. All right, have a great few days off. Thank you.